Example 2. In this example, we're going to look at what happens if we're given one trig function and we want to find the remaining 5. So if cosine is equal to 2/5, determine the exact values of the 5 remaining trig functions for the acute angle theta. So the first step is to write down your 6 trig functions so you know what to do next. So if we look at the problem, let's see what information we already have. Well, we're given that cosine is equal to 2/5. So right away, I can write cosine is equal to 2/5. The next one that I get for free is secant. Because secant and cosine are reciprocals, secant is equal to 5/2. Now at this point, the next step is to actually draw a triangle. So right below here, I'm going to write cosine of theta is equal to 2/5. And the reason I want to write this down is because I can break apart the pieces. The numerator is the adjacent side of the triangle, and the denominator is the hypotenuse. So now if I draw the triangle and just put the right angle anywhere, and I'm going to go ahead and decide to put the theta right here. You can pick either side, it won't matter, as long as you don't use the right angle. So I know that the adjacent side is equal to 2. So this side right here is 2. And I know the hypotenuse is 5. And I know this is the hypotenuse is because it's across from the right angle. So now what we need to do is determine the final side of the triangle. So in order to do that, we're going to use the Pythagorean theorem. A squared plus b squared is c squared. So it doesn't matter which one you call a or b, as long as c is the hypotenuse, or the one that's by itself on the equal sign is the hypotenuse. So I get 2 squared plus b squared is equal to 5 squared. So b ends up being the square root of 21. So this last side is the square root of 21. Notice that this is the opposite side. And now that we have all the sides of the triangle, we can go ahead and solve out the rest of this problem. Okay, so we have sine is opposite over hypotenuse. So it's going to be radical 21 over 5. And we have tangent is opposite over adjacent. So radical 21 over 2. And then now to find the remaining 3 trig functions, or actually remaining 2, we just take the reciprocal. So here you're going to get 5 divided by the square root of 21. But we don't like having the radical in the denominator. So you multiply the numerator and denominator by radical 21. And you get 5 radical 21 over 21. And now we're going to do the same thing for cotangent. So you get 2 divided by radical 21. And then we're going to multiply by the radical 21 to rationalize it. So you get 2 radical 21 over 21. And that's all you have to do for that. So now on your own, I want you to try this problem. If tangent is equal to 1/2, determine the exact values of the 5 remaining trig functions. So use the same strategy we used in the previous problem of drawing a triangle. Alright, let's give it a shot. So we know that tangent is 1/2. So right away I'm going to put the 1/2 for tangent. And then the reciprocal of 1/2 is 2 over 1, which is just 2. So I've got 2 out of the 6 parts right. Alright, so I'm going to go ahead and draw the triangle. Put my right angle in there. Pick an angle, call it theta. Now tangent is opposite over adjacent. So the opposite is 1 and the adjacent is 2. So in order to find the last side, I'm going to use the Pythagorean theorem. And I get c is equal to radical 5. And now I can just go ahead and find the remaining pieces. So sine is opposite over hypotenuse. So it's 1 over radical 5, which comes out to radical 5 over 5 when you rationalize it. Now when you find cosecant, you want to take the reciprocal. So just take the reciprocal of that piece and you get radical 5. Cosine is adjacent over hypotenuse, so it's 2 over radical 5, which is 2 radical 5 over 5. And the reciprocal of that is just radical 5 over 2. The next thing I want to do is go over the trig values of some very special right triangles. So we all remember back from geometry the 30, 60, 90 triangle, and that if you have the short leg, x or 1 or whatever it is, and you want to find the hypotenuse, you double it. And if you want to find the long leg, you multiply by radical 3. And for a 45, 45, 90, remember that the two legs are the same and that the hypotenuse is radical 2 times the short leg. Well, not only do the legs and the hypotenuse have patterns, but the angles also have patterns as well. So you want to go ahead and copy down this chart because you're going to need it basically for the rest of trig and calculus. So if you find sine of 30, sine of 45, and sine of 60, they are considered common trig values that we will use later on. And notice that we can see some patterns, like sine of 30 is the same as cosine of 60, tangent of 45 is 1, cotangent of 45 is 1. You can see how the numbers repeat themselves. And we'll talk more about this later, but it's good to have this chart from the very beginning so we can start memorizing some of these values.